So my GT project is on the Fibonacci sequence and golden ratio in architecture. The Fibonacci sequence was first proposed by Leonardo Pisano Bagolo, which is better known as Fibonacci. The way the Fibonacci sequence works is by adding the two numbers that are previous together to get the next. It always starts with 0 and 1. The first few numbers are 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34. As you can see, to get to 13, you add 8 and 5, which are the two previous numbers. The golden ratio is closely tied to the Fibonacci sequence. The golden ratio is found when the ratio of A, the entire line segment, to B, the larger part, must be equal to the ratio of B to C, which is the smaller part. And if that is true, then you should get 1.618, which is the golden ratio. Well, actually, the golden ratio is an irrational number, which we can only get indefinitely closer to. But 1.618 is generally referred to as an approximation of the golden ratio. The golden ratio is derived from the Fibonacci sequence because as the numbers increase in the sequence, the ratio between two adjacent numbers gets closer and closer to the golden ratio. The relationship between the Fibonacci sequence and the golden ratio. For example, if you take 13 and 8, these are two adjacent numbers in the sequence. And if you divide them, it equals about 1.625. That's pretty close. But normally you would divide the large number by the smaller number to get around 1.6. But you can divide the smaller number by the succeeding larger number to get about 0.618. That is the golden ratio's reciprocal. The ratio of 13 to 8 is pretty close, but what if you divided the 100th number and the 99th? Turns out if you divide them, it equals about 1.618. That is pretty much exactly the golden ratio, way closer than 1.625. The uses of the Fibonacci sequence and the golden ratio is everywhere in nature. For example, snails have used it in their shells. Well, they haven't used it, it's just found in their shells. A sunflower is another example. The golden ratio is widely used in architecture too. The golden rectangle is a rectangle, as shown in the background, that has the golden ratio when you divide the width by the length. The golden rectangle is also special because, as you can see in the background too, if you take away a square, represented in yellow first, this part, which is left over, is also a golden rectangle. So if you take away the orange square here, this part is also a golden rectangle. And if you keep doing that, you'll eventually get this entire picture, which you can start to build the Fibonacci spiral. The Parthenon is a very good example to the golden rectangle. It was built by the Greeks in 447 BCE. The Parthenon has a golden rectangle because the ratio of the height to the width is a golden ratio. This proves that the front of the Parthenon is a golden rectangle. There is no clear evidence that says the Greeks knew and used the golden rectangle to build the Parthenon, but we have found golden rectangles, even if the Greeks didn't know about them. The Forbidden City was built by the Chinese in 1406. It uses the golden ratio in many ways. One example is that the distance from the Daemon Gate to the Jing Mountain equals about 2.5 kilometers. Distance from the Daemon Gate to the center of the Hall of Supreme Harmony is about 1.5045 kilometers. The ratio of 2.5 to 1.5045 is about 1.66. That is really close to the golden ratio. There is still no clear evidence that the Chinese built it with the golden ratio, but again, we still have found many examples of it. The United Nations headquarters was built by architects Oscar Niemeyer and Le Corbusier in 1947. The United Nations headquarters uses the golden ratio because in several pictures, there are three golden rectangles stacked on top of each other, and that makes up the entire building. The width of one is 287 feet. If you divide that by 1.618, it equals 177.4 feet. If you multiply that by 3, because there are 3 rectangles, you get about 532.2 feet. The height of the United Nations headquarters is about 544 feet tall. The reason it does not fit perfectly is because the golden ratio is an irrational number, so it cannot be expressed as an integer. Also because there are many sections in between, like this and that add up. The core is a modern building that was first built in 2005 by Cornwall's Eden Projects, but it was reimagined in 2017 to make it better. The core uses the Fibonacci sequence because it was built in the shape of a sunflower. And, as seen before, a sunflower's petals follow the Fibonacci sequence. It was also built with the double spiral like the picture in the link below. And I'll just show you that. So it might seem a little hypnotizing because it starts with one spiral here and then grows and adds this spiral. And that represents balance between forces. This is their logo, which also looks like the double spiral or Fibonacci spiral. The CN Tower in Toronto is a really good example of the golden ratio. It is also known as the Canadian National Tower that was built in 1973 by a group of architects, including John Andrews. The CN Tower uses the golden ratio because the total height of the CN Tower to the observation deck is about 1.618. So 553.33 meters, which is the entire height, to 342 meters, which is the height of the observation deck, it divided equals about 1.618. That is the golden ratio. So this is my Lego structure that I created with Legos, and it has the Fibonacci sequence and the golden ratio. I was inspired because I found several buildings that are already made of Legos, and I just was inspired by that to build this. So it uses the Fibonacci sequence because the distance between the pillars equals the Fibonacci numbers. So it starts with 1, 2, 3, 5, and ends with 8. It also includes the golden rectangle because the width of each colored section divided by the height is about 1.6. And I did many measurements and calculations to show that. So it uses the golden rectangle because, as shown here, the red part is a golden rectangle. The yellow part added to the red part is a golden rectangle. The green part added golden rectangle, blue part, and the gray part. And that is also the golden rectangle, which means that this whole structure was built based on the golden rectangle. And next, I will show you my building up close. Thank you. So this is my original building. So it uses the Fibonacci sequence because the numbers are here. So 1, 2, 3, 5, and 8. And it also uses the golden rectangle because the red part is a golden rectangle, plus the yellow, the green, the blue, and to the gray. The purple and gray are counted as one section because I ran out of pieces. If my ideas from this page, I started brainstorming. Eventually, I came up with this idea, and I liked the top part, so I started building from there, and that's how I got to my building. Thank you.